Kia ora, Year 12 and 13. Here's the last question from the 2020 differentiation exam. I like this question much more than question 3e. It's a parametric one, and we're given a curve defined by these parametric equations. So x and y here both depend on t, and we're told that t is greater than 0. We're told that we've got a point P that lies on the curve, and at that point the second derivative has a value of 2, and we have to find the exact coordinates of point P. So the most obvious way to do this problem is to use parametric differentiation, and that's how I'm going to do it first. But in this case, sometimes when we have parametric equations, it's hard to find an expression for y as a function of x, but in this case it's pretty straightforward. So you can do this question that way as well. So I'm going to do that at the end of the video, just to show you that you get the same thing. But let's start off by thinking about differentiating with respect to t. So we've got what's going on there? Let's just fix up the pen. So we've got dx by dt is equal to 1 over t, and dy by dt is equal to 18t squared. Dy by dx with parametric comes from the chain rule, so it's dy by dt times dt by dx. So we know that dx by dt is 1 over t. Dt by dx is equal to the reciprocal of that, which is t. So we're going to use all three of these derivatives. So dy by dx is equal to 18t squared times t, which is 18t cubed. What we're trying to do here is to find the point where the second derivative is equal to 2. So to find a second derivative, what we're doing is we're saying, well, we're taking our first derivative and we're differentiating it again with respect to x. Most of you watching this have probably done quite a few examples of second derivatives of parametric, so I'm going to go reasonably quickly here. But when we look at our first derivative, dy by dx depends on t. So we have to use the chain rule to differentiate it with respect to x. So what we're doing is this. We're saying, well, we can differentiate with respect to t and then use the chain rule to finish it off and get the derivative with respect to x. So dy by dx was 18t cubed. So that's going to give me a derivative of 54t squared, and dt by dx was just t, giving us 54t cubed for my second derivative. Now what we need to do is to figure out when the value of that is equal to 2. So we're solving now to get a value of t. So we have 2 is equal to 54t cubed. That gives me t cubed is equal to 1 over 27, and t is the cube root of that, which is 1/3. So we take this, and from there we get x is equal to the log of t, log of 1/3, which I'm going to rewrite as negative log 3. Then y was equal to 6t cubed, which gives me 6 times 1 over 27. And we can simplify that to get what? That's 2/9. So we've found our point, right? So point P is equal to negative log of 3 and 2/9. So that's doing it using parametric differentiation. Suppose that you had a complete brain freeze and you couldn't remember anything about parametric differentiation. Well, let's look now at how we can do it by getting y as a function of x. Well, x is equal to the natural log of t, and y is equal to 6t cubed. Working with this, e to the x is equal to t, and I can now substitute this into here. That gives me y is equal to 6e to the x cubed, which is equal to 6e to the 3x. All I have to do now is to differentiate twice and set the second derivative equal to 2. So dy by dx is equal to 18e to the 3x, and the second derivative is equal to 54e to the 3x. and we have to set that equal to 2. So doing it that way I think is probably easier so far, but we end up getting into, we have to do some exact value work confidently for the next bit. So we have e to the 3x is equal to 2 over 54, which is 1/27th. Right, so e to the 3x is 1 over 27. If we take logs of both sides, take the natural log of both sides, we have this, giving us 3x is equal to the log of 1 minus the log of 27. So 3x is equal to negative log 27. X is equal to 1/3, negative 1/3 log of 27. I guess that's an exact value answer. I don't really like it. I'd prefer to do this. We leave the negative sign here, and then we've got, using my rule that the log of a to the power of b is equal to b log a, we have the cube root of 27, which gives us negative log 3, which is what we had earlier. Lastly, we need to substitute back in, and we get y is equal to 6t, what was it, 6t cubed? Is that right? No, we want y directly from the x. Let's have a look. Yep, so y is equal to 6 times e to the 3x. So y is equal to 6 e to the 3, negative 3 log 3, 6 e to the log of, so 3 to the negative 3 here gives us 6 e to the natural log of 1 over 27, which of course has to give us what we had before, 6 over 27, which is 2/9. So there you go, 2 different ways to do that question. I'm pretty sure that most people who've attempted this one will have done it using parametric differentiation, but you could do it directly. The question doesn't specify how you solve the problem. It just says that you must use calculus and you have to show any derivatives. Okay, thanks for watching, and let me know if there are any other questions that you want videos.